In this video, we're taking a look at amiodarone. We will cover its main mechanism of action, and then we're going to take a look at some secondary mechanisms, and lastly look at the side effects. Let's begin. Amiodarone affects the myocytes of the heart, specifically the ion channels. And the cell membrane of the myocyte contains a lot of different channels and proteins, but to simplify this, we will break it down into the three different ion channels that is mainly affected by amiodarone. Here we see those three channels, and they are the sodium, potassium, and calcium channels. These channels are responsible for the action potential of the myocyte. Outside of the cell, we have a lot of sodium in green and a lot of calcium in red. While on the other hand, inside of the cell, there's an abundance of potassium. And I have also illustrated in green the mitochondria, which contains a storage of calcium. Now, let's begin by taking a look at the normal action potential without amiodarone in action. So there is an influx of sodium that causes a spike in the action potential. As a response, we see an efflux of potassium, which we can see decreases the action potential just a little bit. Because while potassium leaves the cell, calcium is transported into the cell through these calcium transport channels. And so then we see this almost equilibrium, which causes the action potential to have this plateau phase. And this influx of calcium causes a release of intramitochondrial calcium into the cytoplasm. And it's this rapid increase of calcium that causes the cell to contract. Either way, the calcium influx stops, while the potassium keeps leaving the cell and causing a repolarization of the myocyte. And this is the normal action potential without amiodarone. Let's introduce amiodarone into the system and see what happens. Amiodarone binds to the potassium channels and blocks them. And as an effect of this, the plateau phase and the repolarization phase will both be prolonged. And because the myocyte can't be excited again unless it's fully repolarized, it can thereby hinder a rapid signal from, for example, a re-entry tachycardia, because the myocyte is in a non-repolarized state for a longer time. And just as a side note, it's important to remember that the nodal cells of the heart has a different action potential mechanism, and the main mechanism of action of amiodarone is on the myocytes. However, this video will not dive into any further details about the nodal cells' action potential. Now I will briefly mention some of the other effects that amiodarone has. It can bind to and block beta-adrenergic receptors, as well as also decrease the activity in the AV node. These mechanisms can sometimes cause side effects such as bradycardia and hypotension, for example. Amiodarone can also accumulate in different tissues. Here we see the amiodarone is being taken up by the lungs, where it has a toxic effect and can cause lung fibrosis. Moving on to the next organ, which is the thyroid glands. The amiodarone molecular structure contains iodine, which the thyroid uses to produce its thyroid hormones. And so the thyroid can use this iodine and thereby become overactive, and it can induce a thyroid toxicosis. The last organ we'll look at is the liver. Amiodarone can also accumulate here, and as a result cause liver cirrhosis. Now that covers the most important side effects of amiodarone, but it's important to remember that amiodarone has a lot of different side effects that we cannot cover all in this video. Now I hope you learned something, and thank you for watching. And please consider joining the Discord server if you're interested.